fantastic. And let us see if Peter Jateki audio is back. If not, I will show you my submission. It's a physical model of the elevator, and I have a live demo and I have slides. I will share my screen. And this is the FORCE 2020 Elevator Challenge, gentlemen. Fantastic idea of Peter Jateki. And I wanted to make something with the things I have at home. And I created a very simple elevator. And this can be used by father and son, for example. You can build this to teach your son or your anyone you know in your family who is learning electronics, etc., or is a maker, how to build something out of cardboard, a wooden box here, and of course the ESP32 chip, because this is the one we have with the Arduino support and is excellent, documented, etc. So I did the parts. You will need some push buttons, a display, SPI display, if you want to show the floors, the chip here, ESP32, and you will need, of course, your computer, cables, and a breadboard, and you can use an USB charger for power supply. I used two reflective sensors, one on top and the other as encoder, and it will cost you from $30 to $50 approximately to build something like that. And I wrote here, nothing if you are a maker. That was my case. I had all these parts available, so I did not spend anything. The setup of the breadboard and cabling. So you see here the power supply cords. And this is the winch. You need to make a winch on top of the box. Here you see the sensor and a reflective aluminum tape or aluminum paper. I placed two of them 180 degrees apart. And this is a lid, a plastic lid of medicine or something you have at home that will drive the nylon cord or nylon line. And I used a motor here, a servo motor, with a direct drive. This means it's a hack of a servo motor. You can find this on the internet, how to hack a servo motor to get it always spinning in one or the other direction. And then you have, well, here the parts again, and mounted everything together. The LED matrix in action, the SPI LED matrix, and the push buttons. And now I can show you this running. So here you see my camera, and here you see the code. And let me see the interface here. I have always running this interface, and it's telling me it's stopped. This is a multitasking application. So I have, you see, I am working here. I have a working force, but it's receiving all the time over the USB, the message stopped because the elevator is stopped. So when I press the button here, 0, 1, 2, etc., I have here the floors. The elevator will run, for example, to the 6th floor here. And you will see on the display the numbers are changing. And you see it's a multitasker application, so I can ask for help and see the words I have for this elevator. This is Fred. This is Peter Jakaki's icon, and he asked me if to put a small Lego or Playmobil into the elevator, and I found his icon. I hope he likes to see himself traveling on the elevator. It's number 5, and now we arrive number 6. So it stopped, and you see the message changed here. It's showing people can go up and down from the elevator. Now we travel again to floor number 0 here. The speed is variable, so I can change the speed of the elevator. You see I have, oh, it's not on the help. I need to update my help. I can compile at the same time. So let's update my help. Look at this. Compiling a new word, and the elevator is running. It stopped. It stopped, and it goes back. It shows me the GPIO 34, and I can make another help. Help here. Oh, what's happening? Oh, my screen is. This thing here is complicating my life. My help, for example, the spy is to talk to the init of the display. The print a number, for example, I can print a number 4 on the display, and 3 on the display, etc. I can show all inputs to the back. Here are my inputs. And I can also travel without stopping the elevator, traveling to another floor. So I can go up from here, and I can at any time stop the elevator. I am stopping the elevator, and now I travel back, all time back. So these are the things I like in Force, because you can debug your application while you work. You can work with a machine, and you can, for example, show inputs, and I can see the code of this word, and I can see how up is done. It's a servo word. I am working real time with this, and the code is very small. My application is 120 lines. These 300 lines are because of these phones. I need the phones for the spy, for the display. So it became a long program only because of this part of this spy display. It has 180 lines. If I take these 180 lines from the full development, you see I am at 150 lines, 140 lines. And what we show here, and we can learn here, are interrupts, how to work with interrupts. I read the pin 4, which is an encoder. It tells the position of the lift. And I have a servo motor control here, which is a PWM. And here is the speed of my system. And we have also inputs. We have GPIOs used for inputs, which are read on a multitasking scanner, which gives all the time feedback to the program and controls the force interpreter. So there is no program running here. Basically, this is what I like from force. There is no program running. It's just sensors actuating automatically. I press again. You see here, I am working with force. I can see my block files, for example. I can edit and change programs. At the same time, I can press a button and send the sky to the second floor, and it's working in the background. So everything is working in the background while I type here. And I can work and charge other programs as well. So this is the power of force that many people don't know. And this is what we want to show. Simplicity, and something interesting to build. And I think it's a great learning tool and also interesting for makers.